equation.
Yeah.
Okay, so what that means here for us, I'm going to go ahead and rewrite the original. Minus 3x squared minus 8 equals 5x minus 7, is you need to move either the 3x minus 3x squared right and the 8 right, or the 5x left and the 7 left. And they're actually both correct, but generally students move terms to the left.
Sometimes when I do math problems, I usually move, well, where the -7 would be, I would move that to the left and then I would move everything else to the right.
So that's the exception. If the leading term is negative, you sometimes move it right. So
Yeah.
since there's not like a right or wrong here, we can move everything to the right there
All right.
for you. So to do that here, we're going to add 3x squared to both sides of the equation. And I'm also going to add 8 to both sides of the equation here. So let me just get a little more room here on the screen. Not sure why it's not giving me that option here. All right, let me insert some more space. I tend to write big. I don't know if that's good or bad, but it often you'll see me scrolling here. Okay, so now that I got a little more room here on the right hand, so it's 0 on the left. Okay, on the right, you tend to want to do it in descending order. So 3x squared plus 5x, and then minus 7 plus 8. What would that be?
That would be wait, sorry. So that'd be like 1.
Plus 1. Good. And a lot of students, they don't like the 0 on the left, and I don't either. So you can actually just move it to the right like this. And then you're now ready to answer the question, what is A, what is B, and what is C? A, B, and C are numbers, okay? They have nothing to do with the letters, but they are in front of the letters. So A is the number in front of x squared, 3.
So A is 3, 5 is B, and like 1 is C, basically.
Yes. Okay, so just to see if that's clear, and again, if I go too fast, just let me know to slow down, but you'll get these at the end if needed. Let me give you just another quick question. Let's say it was y equals minus 5x squared plus 3. What would A, B, and C be in this case?
Like, so like, okay, so A would be -5.
Good. B?
Okay. That's a trick question. Like,
That's
that's a trick question because there's not a third number. So
okay, so here, let me show you. If I write 0 times x, does 0 times x go away?
Oh no.
Well, 0 times anything goes away.
Yeah, it's gonna be 0. So basically B would be 0 in this situation. And then B would be C.
Right. And let's say I gave you something like this, 8 minus 2x squared. What would A be in this case, B and C?
Okay, so, well, I would still say A would be the -2. But the reason I say that's because it has an x squared, and usually when you order everything, it usually goes from, like, if you have x squared, that'd be the first thing.
That's right. And you probably would want to do this. You'd want to rewrite it as minus 2x squared plus 8.
I would first get everything in order before I answer the A, B, and C, because that's
good. I like that. So what would the
yeah. So B would be 0 again, and then C would be 8.
Good. Okay. We got it. We got it. All right, let's go to number 2 here. I'm going to snip that in. It says show the values of, sorry, let me get it here. Show the values of A, B, and C in the quadratic formula for the equation above. So let me go grab our equation here. Grab that, bring it down. Okay. Do you remember the quadratic formula? Have you seen that before?
Yes, I have. It's just that it's like still new to me, so I don't understand it as well.
Yeah, so the quadratic formula is like the hammer in your toolbox. The hammer is this tool that works for every job, but sometimes it's not the best tool to use.
Not the most reliable.
Well, let's be careful. Reliable means that it works all the time, and that's what this does. It always works, but sometimes, if you're trying to, I don't know, get the batteries out on your remote, you probably don't want a hammer to do that, So sometimes it's too much. Okay.
Yeah.
Now, some students have to memorize this, some don't. You will be seeing this again in other courses, but
Yep.
for now, we'll just leave it as always, put it up in front of you. A couple of things here that could help you, helps most students. Most of the mistakes are made when you substitute the values of A, B, and C into this. And I'll just remind you here that when you substitute, it's good to substitute in parentheses. So I actually will write it here in parentheses so that when you substitute, and this is where most of the errors occur, just substituting and evaluating, that you always substitute in parentheses.
Right.
Okay, so part B, or sorry, question 2 there is asking you to put these values into the quadratic equation, -5. So even though it's positive, I'm still going to put in parentheses for now. Parentheses 5 squared minus 4 times 3 times 1 all over 2 times 1, like that. All right, so the way I read question 2, where it says show the values of A, B, and C, like I feel like we're done. There is more that can be done. Like you can simplify this root, you can do some things here, but I don't read that needs to be done here. What do you see?
Well, sometimes I feel like sometimes the teacher does want it to be simplified even if it doesn't ask it. So I would rather simplify it
Let's do it. Let's do it. So this becomes -5 plus or minus. Now this is where I'd like your help here. Will you simplify what's inside the root here? Keep in mind that you subtract here after you multiply.
That's PEMDAS, yeah.
Exactly. You said that.
So it'd be okay, 4 times 3 is 12, 12 times 1, so minus like 7, I get. Oh wait, I'm being stupid. Hold on.
Take your time, no rush. We got plenty of time.
Is that 5 squared, by the way?
It is, yes.
5 squared, that's 25. So 25 minus 12 is 13.
Okay, all over 2. Now, do you know, without a calculator, the square root of 13? Meaning, like, is it a nice known value?
Oh no, that's a decimal.
It's an irrational. And so the way that this answer is left is you end up dividing both of these by the 2. So
and because there's a plus or minus, it would have like 2 separate, like
exactly. So I'll do this in stages here. -5 over 2 plus or minus 1/2 square root of 13 and 13. And then most teachers like for you to break apart your answers and write -5 halves plus 1/2 square root of 13, comma, -5 halves minus 1/2 square root of 13. A lot of writing there.
Yeah, I actually wrote one of my answers the same way as that, and I got it correct. So I think it just depends on the preference of the teacher, I guess.
Exactly. So a lot of your schooling is about figuring out what the instructor wants and giving them what they want, because they're the one giving you the grade. I am not giving you a grade today.
Today.
Today. Well, ever. I mean,
yeah,
all
but
right.
you never know.
So as we continue to work together, I'll learn that about you. I'll know, okay, she wants us to kind of work out everything fully. Totally get that, and go from there. Let me know if we can move on to question 3.
Yeah, I'm ready. Just let me just box my answer because it helps me. Yeah, I'm ready now.
All right. Can you tell me the values of A, B, and C, please, in this quadratic equation?
All right. Okay. So A would be 1.
Good.
B would be 12, and C would be 9.
Perfect. Now, again, I'll write the quadratic equation down again here, but this one says something about the discriminant. Have you heard that before?
Yes and no. Like I heard like a little bit, but never got full detail.
All right. So the discriminant here, I'm going to grab my highlighter. The discriminant refers to this part under the root. Okay. Just without the root. So it's literally just b squared minus 4 AC. Okay. So will you very carefully determine the discriminant for us? B is 12, A is 1, C is 9.
Yeah. Okay. So it would be like, you want me to put the numbers in there?
Yes. Yes. Basically, I'd like to get the student involved and at least with the calculations, because then you see the formula and you're kind of like, okay.
So it would be like, so wait, so the B that's outside, that's not important right now. Sorry.
Just this over here on the right. Just this part.
Squared is 12. Like it's gonna be 12 squared.
Good.
And then minus 4 in parentheses, A is 1 and C is 9.
Okay. Okay, so you got to multiply before you subtract. Got to take the exponent there before you subtract. Are you generally allowed to use a calculator? Do you like using a calculator? What's
I
kind of your,
do like using a calculator because sometimes when it gets, I can't remember some simple math in my head because
sure.
my brain's everywhere.
Got it. So I'm going to drop in the chat here the Desmos Scientific. This is their actual calculator, not the graphing tool. I really like it. I use a lot of students. You're welcome to use that today. I'm not anti-calculator. It's whatever you are allowed to use in class.
My teacher actually once made me use Desmos for one
Okay,
of I had to graph some stuff.
great. Well, we can do that, in a future lesson here. So 12 squared is 144.
Yeah, 144. Okay, and then minus 36.
Okay,
That would be 108.
good. And that is the discriminant. So the discriminant is sometimes referred to as big D,
Big
uppercase D. Yeah, that's what they call it. I don't I don't make the rules. I just play by the game here.
That's hilarious. I love that.
Yeah. So you'll see that in some textbooks. And so there's meaning to this value, but this is all they ask you. They just say to find the value. There it is. We're done on that problem there. Oh, there we go. 4 actually asks you to make a decision about it. So let's look at number 4 here. All right. So there are 3 possibilities for the discriminant. There is the discriminant is greater than 0. There's the discriminant exactly equal to 0. And then there's the discriminant is less than 0. Okay. When the discriminant is greater than 0, and that's the case that we care about here on the left, you can think of this as like sort of 3 forks and down the road. It says that there are 2 real solutions.
Right.
Okay. We can talk about more about what that means, but it actually is based on whether the D value here is a perfect square. So a perfect square would be like 16. The square root of 16 is known, or not a perfect square. And we can further say something about it. So if it's a perfect square, not only are they real, they are considered rational solutions. And rational means integer, nice fraction, something nice, something you like seeing. Not means it's irrational, means you're going to have a root.
Yeah.
Involved. Okay. So we could fill the rest of this out, but maybe we don't need to. Maybe we'll come back to it if needed, unless you would like me to do that now.
You can just do it now.
All right, perfect. So if the discriminant is 0, let's go back and look at the quadratic formula. What is the square root of 0?
Well, 0.
And if you add 0, does that contribute? And if you subtract 0, does that contribute?
Well, it's just going to keep being 0. So
yeah, so it effectively becomes just this first part. So when the discriminant is 0, there are 2. Well, this is going to say, I don't want to say it that way. They call it a repeated root, repeated or a double root.
Right.
Okay.
So just keep saying the same number over and over again.
Two times. And what this looks like graphically is when it touches the x-axis.
Little smiley face.
Yes. Well, if you're in a good mood, or could be the other way. If you're doing math.
Because I remember, I think when I was in 7th grade, I did pre-algebra, and my teacher mentioned this, and I never understood it until now.
Great. So that's the best case, and this is what I was referring to when I said like the quadratic formula always works, but you would never use it for a repeated root. Meaning like it would be obvious to use something else so that you wouldn't go down this road.
Right.
The other possibility here is when the discriminant is less than 0, that's the square root of a negative number. What do you remember about square roots of negatives, if anything?
Well, the square roots of negatives, there's always a positive and a negative, like.
So yeah, just to be clear, I'm talking about like the square root of -1. Do you remember what that is?
No, I don't think so.
Okay, so this might be slightly out of scope for what you're doing right now, but I'll just throw this in. You get 2 complex solutions, and complex refers to the domain. So there's the real domain, which is what we're used to, and then the complex domain is right next to it, but they don't overlap at all.
That makes a little bit more sense, I guess.
And then not to further complicate this, but the two complex solutions, you can have perfect squares and not perfect squares, depending on the problem.
Mm-hmm. Hmm.
All right, so let me know when you're ready for us to get started on part B, number 5.
Yeah, I'm ready. Let's do it.
All right, we're going to go to about 225 today for the try it out lesson. So we'll just keep going unless you tell me otherwise.
All right.
All right, solve the following quadratic equations using the quadratic formula. Great. So we know we have to use it. Like there's no workarounds here. The first thing you have to make sure of is that everything is on one side of the equation.
Well, yep, that's already been set up for us. Oh,
So step 2 is to identify A, B, and C. So could you do that for us, please?
yeah, just give me a second. I'm writing it down. Okay.
Okay.
A is 6, B is 1, and C is -15.
Good. That operator there, subtraction, always goes with the thing to the right on it. So the next thing here is to write the quadratic formula and to subtract. I'm sorry, substitute in for the values here. So I'll show this here. Parentheses 1 plus or minus the square root, parentheses 1 squared minus 4 times 6 times minus 15, all over 2 times 6.
Mm-hmm.
Okay. So what I'd like you to do is after you get this written down, I'd like you to do the part under the root. That's the most important part to get correct.
Right.
Take your time, maybe do the calculation twice just to make sure.
Okay.
Last thing you want to do is mess that up, basically,
Oh, yeah.
for lack of a better word.
No one would want that. Okay. So 4 times 6 is 24.
That's right.
Okay, and then 4 times -15 is like, let me see, it's -60, I guess, or I think. Oh yeah, I think it's -60. Just double checking that. Yeah, -60. So that would be -60. Do I add those two or do I not?
You really want to multiply these three numbers first, 4 times 6 times 15,
Right.
and then deal with the sign. So in this case, it's negative, which makes this plus.
So it would be like 1 plus 360 basically.
Yes, and you've done that perfectly. It's -1 plus or minus the square root of 361 over 12. And now, here's the the question of the day, right? Do you know the square root of 361? Maybe you do, maybe you don't. Like, is it a perfect square? You really hope that it is.
Well, 360 is more like you could get, like, I don't know how do I explain this. Well, 361's an odd number, and like most of the time, most perfect squares sometimes are odds, but like I feel like 360 would be easier to find if it was a perfect square or not. So I don't know.
What's interesting is that the perfect squares actually alternate between odd and even.
Right. Yeah, that's what I find pretty fascinating because 9's a perfect square.
Yeah, so this one is, and this one, but this one's pretty large. Like I wouldn't expect you to know this right offhand.
I really don't.
So that's where if you got a calculator, you go and grab it. This one is 19. Square root of 61 is 19. You're
Really?
welcome to yes.
That's 19 or 90. I did not hear you.
19, 19.
Oh my God, it is. I just multiplied. Wow.
So there's some value in knowing these, like if you're doing standardized testing, sometimes knowing like your squares up to 20 are good, but we'll just leave it at. Now this is actually two solutions. It's because there's really what's called implied parentheses in the numerator. It's -1 plus 19 over 12 and -1 minus 19 over 12.
Mm-hmm.
Will you attempt to simplify those for us, please?
Yeah, I can try. Just writing it down real quick. I'm a slow writer because I'm writing in pen, so I have to make it look pretty. Okay, so the first one, -1 plus 19, that would be 18 over 12. And if I were to simplify it, 18 over 12, that'd be 3,
Yep.
wait, hold on, sorry.
Good.
Yeah, 3/2.
Good.
That's,
Very good.
I just did that in my head and I was so
Doing
that's
great. Keep going.
so the next one, -1 minus 19, that would be -20. You add negatives, I think. Yeah. -20/12.
Good.
Okay. So if I were to, so I'm going to simplify it by 4, so that'd be -5/3.
Perfect.
Yeah.
Very good.
Thank you.
Very good. All right. So we're going to do number 7 next. Sometimes I do things out of order. One reason is that 6 is very much like the last one we did, but 7's enough different that we'll do this. So this is an example of a problem where you would never use the quadratic formula if you're given a choice. And the reason is you can subtract 2, you can take a square root, things like that here. Now, because you haven't dealt with the whole complex root stuff up here on the right, this is going to be a problem here. So you may want to compare to your lesson notes to see if you actually are able to give this answer, but we'll work through it here and then we'll talk about it.
Right.
So the first thing is you have to expand x minus 1 times x minus 1. So that's FOIL.
Oh my God, foiling is my worst enemy.
Okay, I'll just do it here for you for the first one, just because we are getting a little short on time here for today.
It's not
And
like
then
foil, it's just more, it gets me confused because I always like.
yes, understood. Yeah. So the thing is, it's got to be in standard form, and this one is now, it's now in standard form. It's in that ax squared plus bx plus c form. The original one was not, so you cannot work with it in that form. It's got to be in standard form.
Right.
A is 1, b is -2, and c is 3.
Right.
Okay. So from here, I want you to first calculate b squared minus 4ac. Calculate the discriminant for us, please.
Okay. So for b squared, it's going to be -2 squared. So in parentheses, it would be -2 squared minus 4 times 1 and 3. So it would be 4 minus 12, which would be -8.
Good. Okay, and this is the issue here. This does not have a real solution, as what's called a complex solution. And what I don't know, we'd have to look at your lesson to know if they've covered this yet. It might be one of those things where they are going to cover it in the future, but let's just keep going here, assuming that you do know about this. All right, so here's how we proceed. It's -2 plus or minus, you just told me it's the square root of -8 over 2 times 1. So again, just putting those values of a, b, and c in the equation. You already did the discriminant for us, and I put in the b value and the a value there.
Right.
Is that okay?
Yeah.
So this is 2 plus or minus the square root of -8 over 2. This is the first problem we've seen like this, but now we have to figure out what to do with this. Okay, I'm just gonna write it off to the side here. Let's just say it was the square root of 8. Do you remember how to reduce that from a previous class?
Well, yeah, I do. You put 4, I would say put 4 and 2 in this.
Yeah, you do what's called a prime
Yeah.
factorization, and you look for pairs. Sorry, I'm going a little fast here, just trying to
No, you're
close out this
fine.
problem.
I remember these. You put in the pair that's like, that works, like, so, and because 4 is also a perfect square, so it would work as 2.
Got it. Yeah. So the last part here though is the square root of -1 is what's called I, and that's what I'm not sure if you've seen before.
No, I have seen it.
Okay.
2 of my previous lessons had I in
Oh,
it.
good. Good. So the answer here is 2i square root 2 all over 2. That square root of -8, the negative becomes the I, the 8 becomes the 2 square root 2 here.
Right.
And then to close this out, you divide each of these parts by the 2. And you're left with 1 plus or minus I square root 2.
I don't know what went through some mathematician's head saying, oh, I don't like -1, let's make it an I.
Well, it's kind of like pi. It's the answer. It's the answer to the question of what is the ratio of the circumference to the diameter, which may not make much sense.
Pi is my worst enemy.
Okay. All right. So I'm gonna, if you want to get that down, I'm gonna